Okay, we're going to solve this system of equations, and this right here is actually very convenient for us because here we have negative 2y, and this right here is positive 2y. So when we add these two equations, as we can see, this and that will cancel out right away, and that's very nice. And of course, we just have to continue. 3x plus 4x, that will be 7x, and that's equal to 10 plus 11, that's 21. And of course, we can just divide both sides by 7, so that this and that will be cancelled, and then we get x equals 21 divided by 7, that will be 3. However, we're not done yet because we have to put the 3 back to the original equation, either the first one or the second one. Let's do it with the first one. So when I put a 3 right here, I will get 3 times the x is 3, and that's going to be minus 2y, again, original, so before the we cancel the 2y. So we have the minus 2y right here, and that's equal to 10. And again, right here, just work that out. This is 9 minus 2y equals 10, minus 9 on both sides, and we have negative 2y equals 10 minus 9 is 1. And remember, this is negative 2 times y, so we will have to divide both sides by negative 2. Finally, we are saying that y is equal to negative 1/2, right? So this is the answer. I'll just put this down here for you guys. The x is 3, and the y is negative 1/2, just like this. And that's it. Okay, here we are going to solve this system of equations, and we see that we have a negative 6y and a positive 2y. The signs are opposite already, so it's a good idea to isolate the y, and it's actually not bad at all for this right here. Well, first we have to look for the lowest common multiple of 6 and 2, and the answer to that will be 6. And you see, we have a negative 6 right here already, right? Now we just have to ask ourselves, 2 times 12 will give us 6, and the answer to that will be 3. Therefore, we multiply the second equation by 3. And you see, right here, this is going to be 2x minus 6y equals 79. We are not doing anything with that yet. And then multiply this out. 3 times 10, that's 30x. 3 times 2y, that will be plus 6y, and that's equal to 3 times negative 5, that will be negative 15. Very good, because now you see we have negative 6y plus 6y. When we add the equations up, this and that will be cancelled, right? And again, let's just go ahead and add 2x plus 30y, that's 32. 2x plus 30x is 32x. And this is equal to 79 plus negative 15, that's positive 64. And then we can, of course, divide both sides by 32. That way, we will end up with x by itself. And 64 divided by 32, we get 2 for that. However, we're not done yet though. We have to put the 2 back to either the first or the second equation. Let's go ahead and do that to the first equation. So we end up 2 times the x, which is the 2. And then minus 6y, and that's equal to 79. And always remember to go back and plug in and work out so we can find out the other variable. Work this out, we get 4 minus 6y equals 79. And then, of course, minus 4 on both sides. So that we get negative 6y equals 79 minus 4, we get 75. And now this is negative 6 times y. Therefore, we have to divide both sides by negative 6. So that this and that will be cancelled. And then we just get the y by itself. Well, this is positive divided by negative. We know the answer will be negative. And for 75 over 6, we can reduce that by 3. So if you reduce this by 3 and this by 3, 75 divided by 3, we get 25. 6 divided by 3, we get 2. So final answer, negative 25 over 2. And I will put this down right here. We'll put down the x, which is 2. And then the y is negative 25 over 2. And again, you can put a negative on the top or in the front or on the bottom, but this right here is totally okay. So this right here is the answer. Let's solve this system of equations, and you see that for the first equation, we have x right here, and for the second equation, we have negative 2x. Therefore, it's a good idea to multiply the first equation by 2, so that we get the 2x, and then this will be negative 2x. They will cancel each other out when we add them up. And that's the idea of getting the lowest common multiple of 1 and 2. And we want this to be 2. Anyway, let's go ahead and multiply the first equation by 2. And you see that this is great because this times that will give us positive 2x, and this times that will give us negative 4y, and this times that will give us positive 20. Meanwhile, the second equation stays the same, so we have negative 2x plus 4y equals 4. And again, our goal was to cancel the x first. Now, have a look. When I add these two equations, yes, this and that will be cancelled. That's very nice. And here is a small trouble though. Earlier, I wanted to cancel the x. But here, you see we have negative 4y plus 4y. That will give us 0. 0y, 0, right? Same thing. However, on the right-hand side, this right here gives us 24 plus, this gives us 24, right? 20 plus 4, so that's 24. Now, here is the problem. We have 0 is equal to 24. What does that mean? Does it make sense? Is this true or not? No, this is not true, right? Therefore, the answer for this right here is that there is no solution. There's no solution to the system of equations. Because, of course, 0 is not the same as 24. And if you put down 0y, if you had a y earlier, if you maintain the y, you cannot divide both sides by 0 neither. Right? You have no y's, so that you can multiply with 0 to get 24. No solution. Okay, we're going to solve this system of equations. Notice that we have the x being isolated already. X is equal to 8y minus 2. So I think it's a good idea to just do substitution. Therefore, I will just put this right here, right? You put the first equation into the second equation like that. And we will see that this is going to give us 3 times the x, and the x is that now. Open the parentheses, and you enter 8y minus 2. And we continue. We add a 4y after that, and that's equal to 0. From here, we can solve for y. Of course, go ahead and distribute. 3 times 8y, that's 24y. 3 times minus 2, that would be negative 6. And then, this time, well, that's it, right? So we continue, just write down plus 4y. That's equal to 0. Okay, to continue with this, combine like terms, and we see that this is 28y, and then the minus 6 is equal to 0. And I will just have to add a 6 on both sides, so that they cancel. And then I will end up 28y equals positive 6. And this is 28 times y. So divide both sides by 28. So that this and that will be cancelled. And here we have a fraction, 6 over 28. We can reduce this by 2. So I'll divide this by 2. Likewise, I'll do that right here. And we see y will be 6 divided by 2 is 3. 28 divided by 2 is 14. So y is equal to 3 over 14. However, we're not done yet because we also have to find out what x is, and we can look at the first equation. It's easier this way because x is by itself already. We know x is equal to 8 times y, but we know y is equal to 3 over 14. So I'll just write that down. And then I will just have to minus 2 after that. That's pretty much it, right? And of course, we have to work this out. And you see, this is like saying 8 over 1. And again, we can cross-reduce whenever we are multiplying fractions. Look at the 8 and the 14. And we know 2 goes into 8 4 times. And 2 goes into 14 7 times. And that's the most that we can do right now. And finally, x is equal to, you see, 4 times 3 is 12. 1 times 7 is 7. So we have 12 over 7. But we still have to minus the 2. Like this. Now we have to subtract fractions. This right here is 12 over 7 minus 2. 2 is the same as 2 over 1. I need to get a common denominator, which is the 7. That's multiplied by 7 here, and also 7 here. So we see x is equal to 12 over 7 minus 2 times 7 is 14, over 1 times 7 is 7. And finally, we just have to focus the top. 12 minus 14, that will give us negative 2. So x is equal to, the top gives us negative 2, and the denominator stays the same. So that's what we have. Finally, I'll write down the answer right here for you guys. X is negative 2 over 7. Meanwhile, the y is 3 over 14. And this right here is it.